24-year-old man comes to the physician because his vision has worsened rapidly over the last 2 months. His maternal uncle lost his vision suddenly over a period of 3 months at 26 years of age. The patient's wife and 1-year-old son have normal vision. Fundoscopic exam of the patient shows bilateral circumpapillary telangiectasia. Genetic testing shows a missense mutation in one of the genes of the electron transport chain complex. The probability that this patient's son will be affected by the same disease is closest to which of the following? 0, 25, 33, 50, and 100. So, it's a question of mitochondrial inheritance. It's a question of mitochondrial inheritance. So mitochondrial inheritance, father never gonna transmit the disease to the kid, okay? It is the mother, because what happens during fertilization, ovum is fertilized with a sperm, and a sperm, there is a tail. In the tail of a sperm, in the neck, there is mitochondria. So what happens whenever a sperm enter the ovum, they left behind the mitochondria, their tail, okay? Yeah, what I was saying, so what happens that during fertilization, ovum is fertilized with a sperm, and a sperm has mitochondria in the neck. So what happened during fertilization, they lag behind their mitochondria in the neck. So we got mitochondria only from the mother, not from the father, okay? Yes, so what happens, you never get a mitochondrial disease from your father, okay? We never get mitochondrial disease from father. So what happens, you can see the pedigree here, that in this case, you see mother is giving disease to all the kids. Irrespective of the sex of the kid, all kids gonna have disease. Do you see it here? In the third generation, you see the disease here. Father is not giving disease to any of the kid. You see, father never give the disease, but here mother is giving her disease to all the kid, okay, irrespective of the sex, either male or female. Then this woman is married to a normal man, and she is giving disease to all the kid, okay. This man is married to a normal woman. This man is not giving his disease to any of the kids, okay. So whenever you see such problem, mitochondrial inheritance, it is never transmitted from the father to the kids, okay. It is always from the mother. So what happened, you have to know there are some disease with our mitochondrial inheritance, okay. So Leber hereditary optic neuropathy typically present with acute monoocular vision loss in a young adult, followed by contralateral vision loss in the following weeks or months. A family history of similar ocular disease is common. The condition is passed exclusively from the mother to child, as all the disease inherited via mitochondrial DNA. Since mitochondria from sperm cells are not transmitted during fertilization, so offspring of the affected male therefore are at same risk as the general population. So they are not going to give disease. So other conditions that demonstrate mitochondrial inheritance include MELAS, okay. So you remember MELAS and hereditary optic neuropathy. These are the example of mitochondrial inheritance, okay. So 25%, you're gonna see in if the disease is autosomal recessive, okay. So in case of autosomal recessive, it will be 25%, and what is the probability of transmitting a disease if both parents are have autosomal dominant disease to the kids? What is the probability that the parents gonna transmit their disease to the children if both parents are I think you have it's not 100%, no. So this is how they're gonna make confuse you. You may think, oh, they're gonna transmit. It's actually 75. Whenever you make pedigree, you will see, yeah, that's great. So Dr. Hiren, it's 75%, okay. And there is one famous question in exam that if both parents are autosomal recessive, if both parents are carrier of recessive, like autosomal recessive, you can say sickle cell. If they are carrier of autosomal recessive gene, then what is the chance their kids will be carrier of that, will have that gene? What is the chance their kid will have that gene? There's two questions they're gonna ask. If both parents are carrier, what is the chance their kid is gonna have disease? the kid gonna manifest the disease. That is 25%. But if they ask what is the chance their baby gonna carry the gene, no, it is a 25 is, it will be like it will be manifested in 25%. 25% chance is that the kid will manifest. Okay, so the carrier is 2 by 3rd. Okay, so you make an, so what happened, out of 3 kids, out of 3 there is 2 by 3 probability that the kid will be carrier. Okay, and only 1/3 is the probability that the kid will be normal. 1/3, so carrier means either it is affected or not affected. So the affected one is 1/3, and the 1/3 is carrier, and the 1/3 is normal. Okay, so it will be 2/3. Yeah, 60, you can say 67%. Okay, and it's a famous question, they're gonna ask it, it's a real exam question. Okay,
Thanks for watching. Please give a thumbs up and subscribe for more.